Here the question is, in a hydraulic machine, a force of 2 Newton is applied on the piston of area of cross section 10 centimeter square. What force is obtained on its piston of area of cross section 100 centimeter square? So here is the solution. Let F1 and A1 be the force and area of smaller piston, and F2 and A2 be the force and area of the larger piston. Now, by the principle of hydraulic machine, we know that pressure on smaller piston will be equals to pressure on larger piston. Now, pressure's formula F1 by A1 for smaller piston equals to pressure on larger piston, means it's F2 by A2. Now, let's substitute the values. Force on smaller piston was 2 Newton and area on smaller piston was 10 centimeter square. So it's 2 by 10. And F2, that is force on the larger piston, we have to find. And the area of cross section of larger piston is given 100 centimeter square. So we get 2 by 10 equals to F2 by 100, or F2 equals to 2 into 100 cross multiplication divided by 10, which is equals to 20 Newton. The question is, what should be the ratio of area of cross section of the master cylinder and wheel cylinder of a hydraulic brake so that a force of 15 Newton can be obtained at each of its brake shoe by exerting a force of 0.5 Newton on the pedal? Whenever you will study about the hydraulic brake, you will find that there are the two cylinders. One is the master cylinder and another is the wheel cylinder. Master cylinder is always with a small area of cross section, whereas wheel cylinder with the larger area of cross section. So let the force and area of cross section on master cylinder be F1 and A1. These are the small cylinder, and same, and on wheel cylinder the force on the wheel cylinder be F2 and the area of cross section of the wheel cylinder is A2. Now, by the principle of hydraulic machine, again pressure exerted on master cylinder equals to pressure exerted on wheel cylinder. So we can write F1 by A1 equals to F2 by A2. Whenever it is simplified, we can also write it F1 by F2 is equals to A1 by A2 by the principle of alternando, or we can say F2 is coming towards the left side, so it is coming to the denominator, and A1 from right side of the denominator, it is going to the left side of the denominator, it is going to the right side. The main thing, if F1 by A1 is equals to F2 by A2 is given, then we can also write it as F1 by F2 is equals to A1 by A2. Now let's put the values. F1 is 0.5 Newton, F2 is 15 Newton equals to area of A1 by area A2. We have to simplify it and we will be getting it 1:30, and we had to find out the area of the ratio of the area of cross section. So here we got it's 1:30. Here the question is, the areas of piston in a hydraulic machine are 5 centimeter square and 625 centimeter square. What force on smaller piston will support a load of 1250 Newton on the larger piston? State any assumption which you make in your calculation. Here there are the two pistons which are having the cross section 5 centimeter square and 625 centimeter square respectively. We have to find out the force on the smaller piston, and the force on the larger piston or the load at the larger piston is 1250 Newton it's given. So let's take F1 and A1 be the force and area of smaller piston, and F2 and A2 be the force and area of larger piston. So here the assumption is there is no loss due to the friction. So by the principle of hydraulic machine, pressure on smaller piston is equals to pressure on larger piston. So F1 by A1 equals to F2 by A2. Now let's substitute the values. F1, A1's value is given 5 centimeter square. F2, that is the force on the larger piston, it's 1250 Newton, and A2, that is the area of bigger piston, it's 625 centimeter square. Whenever it was simplified, we got F1 equals to 1250 into 5 divided by 625, which is equals to 10 Newton. Here the question is, the diameter of neck and bottom of a bottle are 2 cm and 10 cm respectively. The bottle is completely filled with oil. If the cork in the neck is pressed in with the force of 1.2 kgf, what force is exerted on the bottom of the bottle? Here the diameter of neck and bottom of a bottle are given. So let's find out the radius. R1 be the radius at neck, which is equals to 2 cm by 2 equals to 1 cm. Here diameter is divided by 2 to find the radius. And A1 is the area of cross section at neck. So its area will be pi into R1 square, since the area of cross section for a neck will be area of a circle. So pi R1 square, that is pi into 1 centimeter square. So it's pi centimeter square. Now let R2 be the radius at the bottom. So diameter at the bottom is given 10 centimeter, which we have divided by 2. It is coming to 5 centimeter. So R2, which is the radius at the bottom, is 5 centimeter. And let's A2 be the area of cross section at the bottom. So here its formula will be pi into R2 square. Pi into 5 centimeter into 5 centimeter equals to 25 pi centimeter square. Now let F1 and F2 be the force at the neck and bottom respectively. Now according to Pascal's law, pressure applied at the neck will be equals to pressure exerted at the bottom. So formula will apply here. F1 by A1 equals to F2 by A2, or F1's value is 1.2 kgf by pi centimeter square equals to F2's value we have to find, and A2, that is the area of cross section at the bottom, which we got 25 pi centimeter square. Now pi centimeter is square is cancelled on both sides, so F2 will be equals to 25 into 1.2 kgf, that is equals to 30 kgf. The second part of the question is, name the law or principle you have used to find the force in part A. We have used Pascal's law. A force of 50 kgf is applied to the smaller piston of a hydraulic machine. Neglecting friction, find the force exerted on the large piston if the diameters of piston are 5 cm and 25 cm respectively. Here let R1 be the radius. Radius spelling is typed wrong. Radius spelling will be RADIUS. E is by mistakenly typed. So let R1 be the radius of smaller piston equals to 5 cm by 2 equals to 2.5 cm, and R2 be the radius of larger piston equals to 25 cm by 2 equals to 20 12.5 centimeter. Here diameters were given 5 centimeter and 25 centimeter, which we have divided by 2 to convert it into radius. Now if A1 is the area of smaller piston, so its area will be equals to pi r1 square. So pi into 2.5 into 2.5 centimeter square, and A2 is the area of larger piston. Same formula, pi r2 square equals to pi into 12.5 centimeter into 12.5 centimeter. Now the force of 50 kgf is applied to the smaller piston. So let's take F1 equals to 50 kgf, and it is the force applied on the smaller piston, and F2 be the force exerted on larger piston. Now by the principle of hydraulic machine, we know that pressure on smaller piston will be equals to pressure on larger piston. So we can write F1 by A1 equals to F2 by A2. Now let's substitute the values. F1 is given 50 kgf. A1 we got it pi into 2.5 into 2.5 centimeter square. F2 we have to find divided by A2, the area of larger piston, pi into 12.5 into 12.5 centimeter square. Now pi centimeter square is cancelled on both sides. So F2 equals to, we got 50 kgf into 12.5 into 12.5 whole divided by 2.5 into 2.5, which after simplification we will get it as 1250 kgf. Two cylindrical vessels fitted with piston A and B of area of cross section 8 cm square and 320 cm square respectively. That means here the two pistons A and B have the area of cross section 8 cm square and 320 cm square respectively, are joined at their bottom by a tube, and they are completely filled with the water. When a mass of a 4 kg is placed on the piston A, you have to find the pressure on the piston A, the pressure on the piston B, and the thrust on piston B. Here is the solution. Mass on piston A is given, it's 4 kg. So thrust on piston A will be 4 kgf. Thrust is the force acting downwards or the force acting normally. So when the mass will be kept on piston A, its thrust will be 4 kgf. Now area of cross section of A is given 8 cm square. So to find the pressure on piston A, we will use the formula thrust by area, which is equals to 4 kgf by 8 cm square. So equals to 0.5 kgf per centimeter square. By the principle of hydraulic machine, we know pressure on piston A will be equals to pressure on piston B. So pressure on piston B will be equals to 0.5 kgf per centimeter square. Now area of cross section B is given 320 centimeter square. So to find the thrust, we'll use the formula. So thrust on piston B equals to pressure into area. Pressure's value is 0.5 kgf per centimeter square, and area is 320 centimeter square, is equals to 160 kgf. Here is the last question of the exercise, question number 14. What force is applied on a piston of area of cross section 2 cm square to obtain force 150 Newton on the piston of area of cross section 12 cm square in a hydraulic machine? So solution is, let F1 and A1 be the force and area of smaller piston, and F2 and A2 be the force and area of larger piston. So by the principle of hydraulic machine, pressure on smaller piston equals to pressure on larger piston. So let's use the formula F1 by A1 equals to F2 by A2. or F1, the value of A1 is 2 centimeter square, equals to 150 Newton, the value of F2, and the value of A2 is 12 centimeter square. So when simplified, F1 equals to 150 Newton into 2 centimeter square whole divided by 12 centimeter square. After simplification, we will get F1 as 25 Newton.